Integration through substitution. Find quantity 4x plus 6 over 4x squared plus 1 integrated. Okay, we can do this. So, first thoughts here is, so you look at this and you think substitution? Well, okay, there's substitution in the title, but more importantly than that, you see a 4x up here and a 4x squared on the bottom. So what's important here is you look at this and you think, okay, if we do a u substitution on the bottom, then we can get something on the top. Let me show you. So we'll do 4x over 4x squared plus 1 plus 6 over 4x squared plus 1 dx. All right, so now we'll look at these two separate. And just in case you're curious, you can do that with the numerator. Denominator, you can't split it like that, but with the numerator, you can. Okay, so we're going to look at these each on their own. Ooh, I'm not sure if I like orange or not. We'll go with it for now. So u equals 4x squared. I'm going to move this 4 to the outside, so I don't worry about it. 4x squared plus 1 du equals 8x dx. Therefore, x dx, I'll put a dx here, integral, just separating the integrals. Du over 2 equals 4x dx. I just took one of the 2's out. That way, even though I moved the 4x out, I could have left it. Okay, so now we're going to write this in terms of u. So we have integral du over 2 times u. Du equals 1/2 natural log of u. It'll be a plus c. And then just to wrap this portion up, I'll have 1/2 natural log of 4x squared plus 1. Okay, so that's that portion. So now we're going to look at the other portion. Change colors, add emphasis. So this guy right there, move him over. I'm going to move this 6 out, and then we're going to have, also going to move a 4 out as well. So I have 1 over x squared plus 1/4. Does that work? I think that works. Yes. Yes, we can do that. So we had the 4x squared plus 1, and that equals 4 times x squared plus 1/4. And then we just took the 4th out, okay? Then I'm going to rewrite this portion real quick. No, I'll rewrite the whole thing. If I was more pressed for time, I would do more, I'd skip more steps, but I am not, so mine will be extra explicit. Okay, so now we have x squared plus, so now it's obvious there that we have a 2 squares. So this is a trig substitution. So you have three trig substitutions you should know. So you have, if you have a square plus another square, then you say x equals tangent of, tangent of u. And then you'll probably have like an a over here. If you have x squared minus a squared, then you'll do x equals a sine of x. And the mnemonic I use for that is if you have a sign in there, a negative sign, then you use sine. And then you'd have x squared plus a squared square rooted, and you would have x equals a secant of x. But this one involves tangent, so we will go with tangent. Okay. Hop, hop. And blue. So x equals 1/2 tangent of u. Okay? And then I think there's a dx up here probably. Probably a dx. And then dx equals 1/2 secant squared of x. Secant squared of u, secant squared of u. Because the derivative of tangent is secant squared. And there'll be a du. So we have 3/2, 1 over, make this a little bit bigger, make that an integral. So we have 1/2 squared tangent squared of u plus 1/2 squared again. And then on top we'll have 1/2 secant squared du. Okay? So now we look to our Pythagorean theorem. Now let's stick with blue. Sine squared plus cosine squared equals 1. And I left off the thetas just for convenience. If we divide everything by cosine, yeah, cosine. Cosine squared, divide by cosine squared, divide by cosine squared, we get tangent squared plus 1 equals secant squared. And then if we divide everything by, or multiply everything by 1/4, we get 1/4 tangent squared plus 1/4 equals 1/4 secant squared. Okay, and that's what we want. So we'll come over here. We still have a 3/2. We have a 1/2 on top. We have a secant squared du. Ooh, this is getting kind of long. All right. And we have the 1/4 tangent squared right there, plus 1/4 right there. And we know that equals 1/4 secant squared. So 1/4 secant squared. Get my canceling color out, which is, in this case, I guess is purple. This is left with 1/2 down here. Divided by 1/2 becomes 2. Cancel, cancel. Equals 3 du. Okay, I'm good with that. And we still have the integral sign. So the integral of 3 du is 3u. And then if we rewrite x in terms of, or rewrite u in terms of x, we then have, back to our original up here, u equals 2x, because we moved the 1/2 over, and then we have to take the arctan. Arctan. Hopefully I have enough room. Almost. So we'd have this equals 3 times the arctan inverse tangent of 2x. Okay, so now we'll add this together with that, and that should give us our final answer. We have, use blue. I always use blue for the final answer. I don't, but I like to. 4x squared plus 1 plus 3 arctangent of 2x. Now let's see what our options are. Hopefully we got an answer that's kind of similar to this. And there's supposed to be a plus c in there, but we'll leave that off for now. Okay. So we have a 1/2 4x squared plus 1 plus 3 arctangent 2. Yes. Okay. I'll be honest, I'm a little bit surprised. Whenever I do that many calculations, I'm like, I had to have missed something. And I usually do. Okay. So, and then plus c. It's a solution. So, to backtrack. So we have this equation up here. We want to take the integral of it. We take the numerator, break it apart. You don't always have to do that. The first thing we notice is that there's the x squared on bottom is one power higher than the numerator, than the x on the top. And so if we take the derivative of the thing on the bottom, we'll get something kind of like the thing on the top. And that should be cueing your spider sense for substitution, which is what we did. But then we have the 6 over here that didn't quite go away. So what we did is we broke that off by separating the fraction into 2 parts. And we took the other part and we had a trig substitution. My general rule in life is avoid trig substitutions if at all possible. They're just cumbersome and difficult. But we didn't have a chance to avoid it, so we went through with it. Then we did a trig substitution. Since it was 2 squares added to each other without a square root, then that was a x equals tangent of u. And we went through it, we solved it, and used some trig rules, and everything worked out, and we got a large, complicated answer, which turns out to be correct, which is good. And that is how you do a trig substitution with, that's how you solve that problem.